Okay, hello everyone. Thank you for coming to my presentation today. So today we're gonna talk about clean code and code quality. And I promise you that if you're gonna follow this presentation, so you're gonna learn how to write clean code even on legacy projects. But first, let me introduce myself. So I'm Andrea Guarino. I'm a software developer, and I work in a company called Sonar. And at Sonar, we want to help developers to write clean code. And myself, I'm one of the maintainers of the static analyzer for Python language. So let's see what we're gonna see today. So we're gonna start by seeing together what are some problems and challenges that we deal with code quality tools, especially when we add them on legacy projects. And in the second part of the presentation, I'm gonna show you a few techniques to how to deal with those challenges, and we're gonna shift the focus on new code. So I'm gonna define a bit better what I mean by new code here, and we're gonna see together a few techniques to help you put the focus on new code. Okay, but first let me ask you. So are you familiar with this kind of tools? So those are linters that you might find in your IDE. So can you raise your hand if you use that? Okay, that's pretty good. So today we're going to talk about static analysis, about clean code, and but first let me define a bit what is static analysis. So static analysis is a technique that we use to actually analyze code without executing it, to say it really in a nutshell. And that it's useful because it helps developers to write clean code. And clean code here, I mean code that is maintainable, so that it's easy to read and to maintain by yourself and by your colleagues. And also, we want code to be correct. So we don't want to have any bugs in our code. And also, we want our code to be secure, because this is also about security. So we don't want to have any vulnerabilities in our code. And why static analysis is useful? Well, maybe if you have to do a code review of this code snippet, maybe with a manual review, it's not so easy to spot that in this code there is actually a problem. And here, so if you look carefully, so at line 203, so you see that the developer is using the extend API of list to actually modify the list. But probably in this case, the developer forgot that the extend API returns none because it modified the list in place. So it means that the option key is gonna be none, and probably at some point it's gonna explode in an attribute error. So that might be quite dangerous. So today for my presentation, I'm gonna use as an example project. I'm gonna use FluxBB. First, because it's a project that I really like. It's pretty popular. It has also a good size. It's 20K lines of code, and probably you already encounter online this software because it's often used to write forum online. And let's say that we want to add code quality, so a code quality tool to FluxBB, and for that purpose, so we're gonna use Pylint. So Pylint is one of the main popular tool for static analysis and for linting of Python code. And in this case, so let's suppose that we want to add that in our CI. And in this case, so we're going to use GitHub Action. So here we have a lot of boilerplate, but the most important thing is only this last line. So that is about just to run Pylint on FluxBB. So as simple as that. So let's suppose that we put that in place in the CI. And so after we do the first analysis, so we're going to see this. So we're going to be overwhelmed by messages on, and you see that even well-maintained project like FluxBB has a lot of messages, a lot of issues to deal with that are related to maybe refactoring suggestions, to, I don't know, conventions that are not respected, and so on. So how to deal with that? And in this case, so we have 1,800 messages. And just as a reminder, the size of FluxBB was 20K lines of code. So it's pretty high ratio anyway to deal with. And so here you see in this slide recap of the messages that we saw in the previous slide. So you see that we have 800 convention that are not respected, refactoring suggestion, a lot of warning and errors. So let's see a few challenges of what I call here the traditional approach to code quality. So the first thing is that okay, let's suppose that you're the maintainer of this legacy project, and so maybe you see all those messages. So the first question that you might ask yourself is, okay, but where do I find budget? Because maybe I will have to spend I don't know, days, weeks, or even months to go there and fix all those existing issues. Then the second problem that I see here is the risk of functional regression, because so let's suppose this is a legacy application, so that it's been in production for since a few years maybe, and so maybe there are indeed some problems, some bugs that happen in production. However, if in your company maybe you have a support team, maybe they already know how to deal with existing problems, so they know how to deal with customers and so on. So if you go there and actually modify the old code, I think you have a quite high risk of functional regression. So you have to be careful to actually do that. And lastly, so a problem that I see is also what I call here the developer pushback, in the sense that maybe you're a new maintainer on this project, so it's not code that you write yourself. And so maybe you might have pushback because maybe even the people that wrote this code maybe left already the company. So you don't have anyone to ask if you don't understand the code. And so I think at the end it might be even boring to go there and try to fix existing issues. So what happened with Pylint usually, so what I observed on some popular projects is that maintainers prefer to really limit Pylint at the bare minimum. So in this case, we see that we have only 4 rules that are enabled for Pylint. And of course, this can be, I mean, can help because then you have much less messages to take care of. However, I think it's not the ideal solution that we should strive for. And why is that? Because I think that static analysis and code quality are really powerful tools that we have in our daily job. And so by doing that, we are limiting a lot the power that comes from those tools. So I think that we should strive for something better. Also, so far I only talk about messages. However, we shouldn't forget that that code quality is not only about messages, but it's also about metrics on our code. And in this case, so I would like to highlight the unit test coverage. And you see that on FluxBB, they already track that they have 44% of code coverage. So it's already very good that actually they track that. However, let's say that at some point, we decide that we want to have 80% code coverage. So does that mean that we should spend days or even months to actually write more unit tests on the spot on old code? So probably we don't want to do that. So you see all those challenges, all those messages, the coverage that is not at the right level. So where do I start to actually introduce code quality in my project? So what I would like to present today is first, keep calm and focus on new code. But first, let me define a bit better what I mean by new code. So I think that the simplest definition of a new code can be thought as a new pull request or a new commit in your project. So in this case, it's really the smaller instance. However, we can extend the concept of a new code a bit further, and maybe if our team is working in an agile environment, maybe with some iteration like in sprint. So in this case, maybe we want to consider new code the period, the duration of the sprint itself. So maybe we might want to focus on the current sprint and maybe put, I don't know, maybe 3 or 4 weeks duration to consider it as new code. And lastly, so if the project is implementing semantic versioning, so we might think also of considering new code, so the new code that were implemented since the latest release that we did. So if for example, we already released the 1.2, and we are working on, we are adding new features for the 2.0. So we might consider the code that goes from 1.2 until 2.0 to be actually new code. So for the purpose of this presentation, so I'm gonna use the simplest of the definitions. So it's just pull request. And in this case, so let's suppose that I want to add, for whatever reason, quicksort algorithm on FlashBB project. So I write my code. Of course, I write also my unit test to make sure that the code is correct and is working fine. And then again, so I have the CI activated. And again, I see this lot of messages that are thrown at me again. And in this case, so if you read very, very carefully, you can actually spot those 3 messages are related to the code that I just wrote, so to the quicksort algorithm that I just wrote. And you see that in this case, it's just, so it's a convention problem, so I forgot to put the docstring. Then there is a refactoring suggestion about unnecessary else, because there is already a return, so it's not really necessary. And lastly, it's about some variable name convention that I'm not respecting here. However, so you understand that if you want to do that for every pull request, so if you want to go there and dig in the log for every pull request, it's not something really scalable, because we have all those old messages that are there. And so I think we should strive to improve this situation. So how can we do that? So maybe the first approach that we might think of is, okay, let's only run Pylint on change files. So, and how to do that? So again, we have the GitHub action here with the boilerplate that we can ignore. And here, so maybe I might think to add Pylint on top of git diff. So git diff just tell us, in this case with the name only flag, it will tell us what are the names that are changed between the current the current branch and the main branch. And in this case, so we only run Pylint on those files. So let's see what will happen here. So you see that it's already much better. So here we only see the messages that are relevant to the FlashBB CLI utils. That is the method that the module that I modified to add the quicksort algorithm. And here again, so I have the 3 messages, the same 3 that you saw before. And this way it's already much easier to actually spot those 3 issues. However, to be completely fair, I'm still quite annoyed about those old messages that I see above, because they have nothing to do with the new code that I just wrote, right? And in this case, so the CLI utils module was pretty small. However, if you think that you have to maintain maybe a project with a very, very long file, and that happened, unfortunately, so we might end up in a situation that is more similar to what we saw before. So with the long list of messages that we have to deal with. So I think we should strive for something better. But first, let me formalize what I'm trying to do here. So here I'm introducing what I call the clean as you code methodology. So clean as you code methodology means that the quality of your code should be measured only on recent changes, so on new code. And again, so we want to focus on new code, but we would like to focus only on new lines of code that we just wrote, so not on new files. And again, here I will remember that this is not only about issues and messages, but we would like also to put the focus on the metrics. So I think that also metrics should be defined only on new code. And so if you remember here the recap slide for the entire messages that we saw before, so what I would like to have with the clean as you code methodology is to have only the 2 convention project that the 2 convention messages that we saw before, and the 1 refactoring suggestion. And then in this case, no warning and no error. And again, so you might remember that one challenge was about where to find budget. But hey, in this case, we are just implementing a new feature. So to actually go and fix those problems that are reported by the static analyzer tool is something that is really part of the job, right? So you don't need any dedicated budget for it. So it's not a problem anymore. About functional regression, well, to be fair, you always have a risk of functional regression, right? However, in this case, the scope will be much smaller, so because it's only on new code. And I think in this case, so the code quality tool can even help you to prevent some functional regression, because in this case, maybe there is something that you didn't think of. So I think it might be helpful in pair with the unit test that you're going to write, of course. And lastly, about the developer pushback, I think it's not a problem anymore, because in this case, it's a code that we just wrote. So I think that we already have a sense of ownership on this code. So this is not a problem. And as a bonus point, I think you have also the opportunity to learn something new. And what I mean here is that maybe the code quality tool will tell us something about, I don't know, a new feature of the language that we are not aware of. And so I think it could be really a nice opportunity to actually read carefully what the static analyzer is telling us, because the scope it will be much smaller. And so we can actually understand what are the messages that Pylint is telling us here. So we saw together the first step. So as a reminder, was to only focus on the change files. However, with the clean as you code methodology, we would like to go a step further, so to only focus on the change lines. So how to do that? And I would like to introduce a tool that is called Darker. So have you heard of Darker before? Can you raise your hand if you did? OK, that's great. So Darker is a CLI tool that can be run on top of code quality tools, in this case of Pylint. And so again here, so if you remember the GitHub action, so in this case, I'm going to run Darker, and I'm going to instruct Darker to compute the difference between the main branch and the current branch. And in this case, so it's going to run Pylint on a FlashBB again. So it's as simple as that. And so if we do that, so you see that the next time that we execute this, we're going to only see the 3 messages that are relevant to the quick sort algorithm that we just wrote. And I think this is really the fundamental step of the clean as you code, because here you have the focus put at the right level, so you're not bothered with old messages anymore. So as an alternative, I would like also to suggest Sonar. So Sonar is the company I work for, and at Sonar we actually put in our products the clean as you code. Really, it's a core feature of our product. And in this case, again, so Sonar has its own GitHub action that can be used. So in this case, we would have to produce a report for Pylint. So in this case, we're going to put everything in this Pylint report.txt. And then the Sonar cloud, so it's the cloud version of Sonar, is going to be fed with this report. And so once we modify the continuous integration with that, so we're going to see actually that in the pull request, so here we are in a GitHub, so we're going to see this message from the Sonar Cloud bot, and you see that it's reporting us those 3 codesmell. So codesmell is the terminology that is used by Sonar to indicate messages of Pylint. And you see, so if we click on one of these links, so we're going to end up in the Sonar Cloud UI. So Sonar, it prefers to be more graphical interface in comparison to Darker, where it's more CLI-based tool. And in this case, so you might recognize that we see again directly in the code that we have the missing doc string, the necessary else, and the variable name x that doesn't respect the convention. And you see that we only see those 3 issues. So again, we have the focus at the right level. Also in Sonar, we have what we call the quality gate. So the quality gate is an indicator that tells you if your code is production ready or not. And in this case, it's not production ready because we have those maintainability problems to deal with. And you see also that we have the coverage that is not at the right level. So in this case, we want to have coverage at 80%. However, in this case here, we have 75.9%. However, you might remember that the code coverage of FlashBB was at 44-something%. So you see that here we see a different number, and that's because the coverage is computed only on new code. And I think that this number is much more actionable because it's much easier than to write more unit tests to make sure that it actually fills up the 80% that we need. And here you also get an estimation of what's gonna be the code coverage once we merge this pull request on the main branch. And I think this helps you to deal incrementally with improve the code coverage. And here you might spot that we have also this one bug that is under the reliability section. And why is that? Is because Sonar has also its own static analyzer for Python. And in this case, it was able to find one bug here, is that I forgot to add the raise keyword on this exception. And so it means that if the array is going to be none, then at some point it's gonna blow up. And so we're going to have an attribute error again. So you might remember that the title of this presentation is to forget about the old code. However, that was kind of a lie, because so you know that when we have to add new feature, we anyway have the opportunity to modify existing code. And while we do that, so if we put in place the quality gate, so it means that the new code that we're gonna write, so even the one that modified the old code has to respect the code quality standard. And so here, if we just do an assumption that maybe after 1 year, we had to touch 20% of the existing code base, it means that 20% of the existing code base is going to be clean. And here, if we project this to 5 years, maybe we're going to touch the 50% of the existing code base, and it means that half of the code base is going to be clean incrementally. So if you think that I made up this number, so you might be right. However, so you might be interested to actually see this article from Eric Byrne. So he actually built a tool to actually understand what is the percentage of commit that is going to be modified or that is still present in a code bases. And you see here, for example, we have a few popular projects, and we see Django in this case. And you see that on Django project, after 5 years, so 0.5% of the commit are not there anymore. So it means that they had to be refactored somehow. And that means that could have been an opportunity to actually clean the code incrementally. So to wrap it up, so we saw together a few challenges with dealing with code quality tool, especially on old code, on legacy projects. And we saw together a few techniques that were based on the clean as you code methodology. The first technique we saw was based just simply by using the git diff. The second, more advanced technique was based on tools like Darker or Sonar that really that compute the diff only to show you the issues on change lines. And finally, we also see a way to deal with the code base, even the old code base, and to clean up incrementally this old code. So that's all what I wanted to say. So if you have questions, I'm happy to answer.
We have a few questions from Slido. First one is, what's the difference between Pylint and Pylance?
So to be honest, I don't remember. I think that Pylance is the tool from Microsoft, if I'm not wrong. So I think it's just they are two different code quality tools. So probably each has its own strength. And but yeah, I don't know precisely what is the difference between those two.
Okay, thanks. Do you define clean code only in terms of static analysis?
Well, I think it depends. I wouldn't say so. I think that clean code can be defined also in larger terms. And for example, I don't know, you might think that the number of unit tests that you have or any other metrics that might be relevant to your code can also part of the definition of clean code. However, for the focus of this presentation, it was mainly based on static analysis.
Thank you. Another question is, what's your favorite stack of linters, formatting tools, and so on for Python projects?
Stack of linters.
Sorry?
So the stack of linters for Python project?
Yeah.
Okay, that's an interesting question. So I might be a bit biased because I work for Sonar, so I think Sonar is really useful stack to have in mind. Then I think also I would recommend tools like Black to deal with styling. So I think this is also very useful. And I think also FLAC8 is a really useful tool that also deal this with good messages and not too many false positives.
Thank you. At the moment, we don't have any more questions on Slido, but if there's anyone who wants to ask a question, I'm happy to reach out.
Can we set the local linter in the code editor to start looking only from a day, only for from that day to the new code?
Yeah, I think that's gonna be possible, and that would fall, let's say, in the second definition, more or less. So you can actually say from what day you want to let's say to track clean code, and so that's also possible. Then I think it depends also on the tool that you're gonna use. So I'm more familiar with Sonar tool, and I know that in Sonar you can define the exact date from which you want to start to consider new code.
Sorry, it's a bit random, but do you see those generative models playing a huge role in the future in terms of static analysis of code, or not really?
That's an interesting question. So I think they might be useful, and they already are proving to be useful. However, yeah, I'm really excited about what they can bring to it. So yes, I think it will be eventually, but let's see.
We have another question from Slido, and it's: do you use pre-commit?
Sorry?
Do you use pre-commit?
Pre-commit. So I think I think that pre-commit might be useful. Me personally, I don't use it, so I prefer to rely more on the CI check, and also to rely, let's say, on the ID. So if I talk about Sonar, for example, Sonar has also the correspondent product that it's SonarLint that is going to run on the ID, and that's something that could help you to be synchronized, so to also see the same issues on the IDE, the same issue that you would see reporting then on the CI. However, I think that for team is more useful to actually have a more centralized approach, so to have the continuous integration in place, because yeah, otherwise to put the pre-commit on each developer might be a bit more complicated.
Thank you. And we have time for one last question.
Sorry, just curious. Do you also do static type checking? MyPy, for example, and
yeah, we do. Yeah, actually, we do also type checking. We have a different, let's say, objective than MyPy, because in our case, we want to report cases that might produce bugs or, let's say, maintainability problems, while maybe MyPy wants to go a bit further. And also, we don't enforce developers to have type hints, so we try to do type inference ourselves, so to actually guess what the right type is.
Great. We don't have time left, so thank you so much, Andrea.
Thank you.